Hi there, Pre-Calc students. Another online lesson, this time 1-6, modeling real-world data with linear functions. Make sure you have your graphing calculator in hand. We're going to be working on that. Might be a little interesting to do that online-wise, but we'll give it a shot. And we'll be practicing a lot of this stuff in class, so not to worry if you don't totally get it today. Anyway, taking a look at these three scatter plots up here, we just want to compare and contrast those a little bit and give some descriptors to them. So first of all, which of these scatter plots appear to be linear? Well, it does look like the first and second ones do definitely appear to follow some sort of linear pattern, but this one looks like kind of a blizzard and really no rhyme or reason to these graphs. So as far as linear, I guess I would have to say the first one is a yes, second one is a yes, third one is definitely a no. Now, in addition, we can also talk about the relationship, and by relationship we mean is the slope positive or negative. And clearly you can see on this first one, as the scatter plots go up, we're going to say that that's a positive relationship. The next one, as from left to right the lines go in a downward trend, we're going to call that negative. But in our last one here, when there's really no strong relationship between any of those lines, we're going to say that there is none. There we go. All right. And finally here now, the correlation. What we mean by correlation is how well these points fit onto a straight line. And correlation always ranges someplace between +1 and -1. And you notice I used the variable r. That is the variable we'll always use to talk about correlation. So kind of strange getting used to that. Now if your correlation was +1, it would have a positive slope and every point would be exactly on that line. Also, if your correlation was -1, there would be a negative slope and every point would be on that line. So of course in real world data, it is rarely, probably never going to be a perfect correlation either one way or the other, but we'll be able to get a number that will describe how strong that correlation is. So looking at the first one here, actually comparing our first and second one, which one would you think would have a stronger correlation? Well, because our second one is more along, the points are more along a straight line, that's going to have a stronger correlation, where the first one won't be quite as good. So we're going to say, probably for the first one, get my pen up here, I'm going to say fairly strong. Second one, I'm going to say it's definitely a strong correlation, and by strong I mean this R value here is going to be closer to 1 or -1. Won't be quite as good on this first one as the second one. And our last one, of course, we'll get a correlation number for it, but it's going to be pretty weak actually. All right, now and here's where you're going to have your calculator in hand here, your graphing calculator. And you might have done some things like that before, but I'll try to describe some things and point out some keys to hit. You're going to want to pause this video quite a bit as you enter some data in your calculator and look at these screens. And again, don't be overly concerned if you don't totally figure it out, but if you can practice this ahead of time, this will be very good. As far as writing things down, for notes, probably not a lot of stuff that you're going to do. I'd like to see that you have this data in your calculator, though. That'll count for your notes for tomorrow. Anyway, here's the data we're going to be looking at with the Olympics that just got done not too long ago. Here's the women looking at their events. And as you might guess, the percentage of the women's events in the Olympics have certainly increased over the years, where a mere 2% back in 1900 all the way to 46.4% in the Olympics that were just completed. So a really nice progression for the percentage of events for women in the Olympics. Now, the first thing you want to do is enter this data in your calculator, and notice this key that says Stat, which is right here. It's close to the arrow keys. You want to select that, and the first menu that comes up looks something like this. And you want to be in the Edit menu. You want to choose Edit, and it'll take you to a screen that looks like this that has several lists, L1, L2, L3. And you're going to basically enter all the years in L1 and all of the percents in L2 on your calculator. That'll take you some time to do that, so why don't you go ahead and do that now. Pause the video and do that. Alright, once you have all the data in there, what we'd like to do now is calculate this thing called a linear regression, or otherwise known as the line of best fit. And that's going to give us a nice line that will fit the data pretty well. Later on in another slide we'll see how strong that correlation was and things like that. So anyway, you have to go back to the Stat key, the same one you had before, but this time make sure to have the Calc menu highlighted. Scroll down to number 4, LinReg, that stands for linear regression. Now once you select that, you'll get something like this. It'll spew out an A, a B, an R squared, and an R. It's possible you might not get this R squared and R. I'll show you in class how to get that. Remember, R is this correlation coefficient. As you can see, it's at 0.978. That's quite a strong relationship between the years and the percent of women's events in the Olympics. So our actual line of best fit then would be the A and the B. A in a sense would be comparable to the slope, 0.37, and obviously it's a positive slope. The number of events are going up. B then is considered to be the y-intercept, maybe not that realistic in this case because of starting in the 1900s or 1800s whenever the Olympics started. Nevertheless, that's our equation. Now, just to show you another thing that we can plot points on the calculator, you've probably done that. There's a key that says Stat Plot. That's way up here in the upper left, but you have to hit the second key and then y equals to get to that Stat Plot. That'll get you to a menu that looks like this. And you want to select number 1 and go in and select the one that looks like a scatter plot. Again, we'll help you more in class if you're not sure about that. Then the next thing, in order to get the graph visible, you need to go to your Window key. That's way up in this top row here as well. Here might be a suggested window that you could use to get a good view of your data. Again, please pause this video to take time to enter in all this data for sure. On the next slide then, when you do graph this, and there's the graph key right there, here's what your actual stat plot should look like. Clearly you can see that there's a strong positive connection between these variables. What I did next, and we'll probably show you in class a little bit more about that, you can actually get our previous line that we calculated, that line of best fit. You can actually get that line to appear right on your graph here. It's kind of a nice visual to see how it looks. You can see there are several points that are a little bit under, several that are above it, but this line that was calculated is the actual line of best fit. Another name for that is the linear regression model. And then another nice thing you can do is use this for prediction purposes. And you can go to your table set, that second and window, and we'll show you how to do that in class a little bit. And then if you go to the table, which is second and graph, you get a nice table here. This shows in 2012 the predicted percent was 40.77. Notice that's a little bit less than what actually was. But it's going to be different because of all the data put together on this line of best fit. But if we wanted to make a prediction for the percentage of women's events that there would be in 2016 at the next Olympics in Rio, here it is right here. Notice that's a little bit less than there currently were this year. And that may or may not be true, depending on the Olympic Committee's actions, I guess. But still a very powerful thing. So this thing you're learning about here, I would say in business and industry, is just huge, where a corporation might take some data and analyze it and use it to make a prediction for, say, a certain product's use and popularity in years to come, or any number of things. This predictive power is very good. This is an example of a mathematical model. The model we're using is just a linear model, but there are all kinds of other mathematical models that are in use this day and age. Anyway, we'll keep working on this, so hopefully this gave you a good intro on that, and we'll see you in class.